as I can get.
So my talk is about unlocking new potentials in Flutter with shaders. If someone told me this or gave me this title probably 3 or 4 years ago, I will be very skeptical because one thing Flutter promised me from the beginning was you never say no to your designer. Whatever your designers give you, you will be able to do it. And that was like got us in kind of troubles, but we had to go with it for a couple of years while we are learning Flutter. But then some things happened and they changed my mind. Obviously, the type of designers I was working with changed, and also the type of designs and the type of clients I had to work with also changed. So I had to unlock some new potentials, and that's what I will hopefully try to share with you today. And we'll be able to see a couple of really cool demos, some of them made just for the event so that they can be exclusive. So chapter 0. So we have to go back to see the limits, and I have to take you back on a little story or a journey before. I'm pretty sure most of you probably have seen this in the Flutter documentation. This is a bit bigger. It's a comparison between what happens when you are scrolling your application between Android and iOS. So on the left, we have Android, and the right, we have iOS. And you can easily tell which one is more beautiful. Like the iOS one seems to be as of today, but the Android one seems like definitely in the 90s. So I didn't like that for a very long time. I was wondering why is it like that, why they never changed it. But then Android 12 came in. Sorry, this is all in Chinese so that you don't focus on the language, you just focus on what's happening there. They changed actually how the how it's happening on Android. I think it was 12. Yes, so on Android 12 now we finally have something that looks as good or even better than the iOS one. I saw this, I was super excited. I went to the Flutter repo, I created this issue, and it's probably now one of the most commented ones, or like thumbs up based on the Flutter team, because that's how they prioritize what they work on. But yeah, it was probably on the same day. I didn't even finish. I saw this in the announcement, I created the issue, and I thought I'm clever enough to suggest a solution. So I told them to go ahead and use some widgets, and they felt like, yes, I can do this. I can just add a little bit of spacing when you scroll at the end, decide how much spacing to add. Using a transform widget, I'm going to scale on the y-axis, and we'll end up with the same effect. Obviously, that's not the case and will never be the case. If we take a closer look at what's happening here, you will not see it from the first time. You'll probably need to take a couple of screenshots and compare them one next to the other. But what's happening here is not just a uniform transition where everything is scaling down and a little bit more spacing is added. You can see the text is getting larger on the y-axis. The icons are getting larger on the y-axis. But more importantly, it's happening on a larger amount. Like if the value of the transition is, let's say, 5 to 9 at the top, it's less at the bottom. So it's non-uniform. So it will take a couple of minutes to notice that. But the question is, how are we going to be able to achieve that with a widget like transform widget in Flutter? It's uniform, and whatever values you provide to it is going to apply to the entire thing. And that's when I was introduced to shaders. This is just to showcase what the Flutter team ended up doing right now, something very similar. This is the current implementation. If you use the latest version of Flutter, this is the current implementation. It looks very similar. They tried to mimic it, but the issue itself hasn't been closed because they still didn't get 100% match with what the Android team has. That's why I was introduced to the notion of to the notion of shaders or fragment shaders in general. It was mentioned by the Flutter team that that's what is needed in order to get that effect to work reliably. But then once you see something, you always ask what other places this actually exists in. So here we'll take a few other looks at some examples. For example, here, this is a blur. You could say that this is called the lens blur. There are multiple types of blur, as we will see in a bit. But what we are looking here is something that will not be able to achieve with Flutter easily. Like we cannot just say use the blur widget, backdrop widget, or whatever other widgets that are provided by Flutter in the blur. We will not be able to achieve something like this because it's more custom than that. Here are some other examples. For example, here The first one is called Books Blur. It's literally the cheapest blur ever, and it's just like you go through and you make it look something blurry, but it doesn't actually change a lot from. It doesn't make it beautiful. It just makes it blurry. We have the radial one. We have the tilt shift. This is a very common blur where you want to make stuff in the middle look smaller, and you probably have seen it in the Sherlock Holmes TV show. They make use of that effect a lot to make the taxis look a lot smaller. We have here the shape blur. We have another one called, I think, the all blur. I mean, at this point, I forgot. All of them are almost the same. It's just blurry. Yes, more blur. I think this one is the surface blur. The other one is the lens. And finally, we have the Gaussian blur. The Gaussian blur is actually what is used in Flutter. So this is what you can achieve with Flutter if you use the image blur widget in Flutter. This is what you can use. Obviously, you can say it has multiple parameters, so we can use it to do anything. And these are the whole parameters that are provided by that widget. These are like the blur. Is it going to be on the x-axis or the y-axis? And you can play with that, and you can see how much the blur is affected. We also have the tile mode. The tile mode is, you can find it in other widgets, not just the blur, but it's a good chance to understand the difference and what to make use of it. So for the blur, because it has to go through every pixel on the screen and tries to apply the effect on that blur, imagine we are at the edge. So we are at the edge here, and there is nothing on the side. So what color are we gonna look at to decide what will be the color of the final pixel? And that is literally why it's called an edge case, because it's at the edge and we don't know what's beyond that edge. So we have multiple tile modes. We have mirror, for example. Mirror is going to say, look at the last pixel on that position and mirror it, and do the same for the other one. Mirror is almost the same as repeated. Repeated is just going to duplicate the same pixels. It's not going to mirror them from the origin, but it's actually going to go through from the beginning to the end, and it will replicate it just on the left or on the right or whatever we are asking it for. Clamp, you will see that there are voids in multiple places. Those voids are coming because there is nothing that they can take colors from, so it ends up like that. We have decal, which is like clamp, but it is more transparent. It doesn't have the black holes, but it has transparent ones. Like if we remove the background, it will be transparent. So that's the difference. But why I'm showing you all of this is because all of what we have seen is whatever Flutter provides. There is nothing else that Flutter provides more than that in order to create blurs. And the question is, how are we going to be able to implement all of those blurs? We have seen probably just 9. Like there are other, not hundreds, but there are actually a lot other blurs. And if your application is image processing heavy or needs to have like something very visually aesthetically pleasing or very custom, you cannot do it with a blur. So that is also another thing where even with we can do everything with Flutter, we will not be able to do it. But now we go to some other simple examples. Like I'm going to go through these very easily. So for example, here, this button. Like, what's the starting point? Like, how are you going to implement this? What's the starting point? Like, what are we going to do? These are some effects. For example, the water ripple effect. We'll say let's start with a custom painter, but yeah, we'll be a custom painter for a while before we figure out how to simulate it in a way that it is as smooth and as real or imitating the real water effect as possible. This is another example. All of these examples, they seem to be random, but we will see in a practice and how actually they turn out to be great for visual effects in real applications. Like this one here, no one uses this effect. This is 2008. No one uses this effect in your application in today. But we will see some real examples where it can make it look even better. So this, obviously, yeah, this is just wave distortion. We can do something like this with a custom painter. The reason I'm putting it here is the same for the zoom blur and for the noise and all of these. It's not because they are not possible to do with a custom painter. It's because even if you do them with a custom painter, the application is going to scream for help because it will be drawing a lot, and it will be drawing a lot every single time the screen has been refreshed. So we will see a lot of junk in the application. It's not because of whether it's possible or not is whether it's possible or not pay on the on the refresh rate that's possible by the device. This is another example. I'm going to pause here because it has some real nice examples by two people in the Flutter community. One is called Creative or Maybe Not. He created a whole case study around this meatball effect and how to achieve it. He actually did it literally with a costume painter, but at the end, he wasn't able to achieve the smoothness of whatever is available with shaders. So he goes into the point to validate that we actually need shaders to achieve something as fast as this. Same use case by Super Declarative in his channel Processing, where he discusses this exact same problem. Now we go to chapter 1. We understand if somehow something is done, then we can understand how we optimize it. So let's take a look. This is an image. This is a blurred image. What happens in between is definitely not magic. It's something that I can definitely tell was the question you asked in the previous session. It was about math, right? It was about math. Yes, I know it was about math. I heard that word. So it's not magic. It's actually just math, and we'll show how that works. I created this very simple demo application which explains how the blur effect works step by step. So if I go here to this interactive example, so here I'm simplifying it. These random colors are just, you can imagine them as a picture, but they are not. Every picture is just a random set of colors. So let's simplify that and look at it this way. And we want a blurred version of that. So what happens in between is something very simple. You go into the color, and then you go to create a kernel. This is 3 by 3. It can be bigger to look at the pixels around it, and then try to smooth them out. So if it looks at all the pixels here, you will see the a value here, which is just like a kernel value that will calculate based on the color of each one of these, and then try to put an average. That average is going to be the result of the final color. So here, if I click here, like this, it was double click. I forgot what they mean here, but yeah, whatever was that, I think, yeah, it's double click. So every time I click on it, this is the result. The final result is there. Is definitely a different color, but it is the color that combines the colors around it and averages them and gives you the final color. That's what we call a blurred version of it. So here, if I try to do it to all the values here, it will end up with the blurred version. We are not using the most optimal blurring function, and we are not using obviously a good picture to show what the final version looks like, but it's not too far away from it. But at the same time, we can definitely see that it is lighter and it is a bit different. So as I said, if this is just logic and it is just math, then what would be the problem? Why we wouldn't just go ahead and go to a costume painter, take a look at the picture, read the pixels around it, and then decide to create the new picture? The problem here is that when you use a costume painter, that code is dark code. The code is going to be running on the CPU. We take a simple example, an image that is 1,000 by 1,000 pixels, and then we try to apply the blur effect. I mean, it's very, very applicable. Everyone can just go ahead and try to do it, and you will see that your application is no longer going to be responsive, because the CPU has to process now 1 million pixels, and that 1 million pixels is like the minimum. Like if you have a very small image, all the images that we are seeing these days is like way, like 5 times more than that. So if we're doing an like at least 10 operations, as you have seen, we take a look at the colors. So if we take a look at the neighboring color here, and neighboring color here, neighboring color here, each one of these operations. So if we do 10 operations here and there, we simply have 10 million operations that's happening just in order to blur one simple image, and that is not acceptable. That's why we will be introduced to the GPU, which I'm pretty sure all of you know that it is the graphical processing unit. I always get this joke that but nobody gets it. But it's for example, here with the CPU, what do we have is that what we are doing is the operations. It will be sequential. Every time we are trying to look at the pixel, we will have to look at this, and then the next one, and then the next one. It will be one operation after the other, one operation after the other. It's obviously super fast. We can do a lot of that, but the problem is it will not be as fast as doing all of them at the same time. And that is where the GPU is actually made for. It's literally made to do this. It's made to do operations that are highly parallel. We can obviously go back to the CPU where we can use threads, isolates in Dart, and all of that, but that's not going to take us any point that is nearby the GPU, because the GPU is doing it by the hardware. It's not doing it with the software. There is no limit on the amount of threads that you can spin, because the GPU, what we will be seeing is that for every pixel that we have, there will be a thread that will be running your code for that specific pixel. So obviously, as we know, with Dart and the CPU, even with other languages that are not Dart, but are highly parallel, like Rust or C++, will not be able to achieve something as fast as the GPU. So how do we access the GPU in Flutter? That's called shaders. Shaders is the notion of a program that runs on the GPU. So when I say shader, it's just a function, but it runs on the GPU instead of running on the CPU. There are multiple types of shaders, but fragment shaders or pixel shaders are literally just the last type of shaders where you can actually write some logic and end up with a result around it. So with the newest versions of Flutter, I think this was just by 2 years from now. It wasn't very recent, but now we can have access to fragment shaders. We cannot access any of the others, but this one is the last step and it is the fastest to go through. Flutter already uses shaders. For example, we have seen in the previous session about gradients. Gradients are literally shaders. We have seen blurs in this session. We know what blurs are by now. They are also shaders. So if we want to take a look, for example, at a simple case study here, the image filter, you will use it if you want to use blur effect in any, like whatever. Is it backdrop filter? Is it a box shadow? Whichever kind of blur you want to apply in your Flutter application, you will have to go through this image filter API. And if we dig deep, because Flutter is open source, not like Apple, we can take a look and see what's actually happening behind the scenes. What's happening behind the scenes is creating something called Gaussian blur. As we mentioned by now, Gaussian blur is just like using the Gaussian function that is supernatural and like has a bell curve that looks more natural to the eye than any other blur. That's why it's the most popular, and it's also somehow cheap, but not the cheapest. So we take a look at it. Now we are in the engine side. We left the Flutter framework. We are at the engine side. We're looking at some code, a little bit more, and finally we arrive at this point here where we have an entities in impeller, and all of them are kind of shaders. And we can see, take a look at the first shader that's used here, which is the Gaussian blur. If we take another deep dive, we will find other types of blur. For example, they try to optimize when the blur is not needed to be fully Gaussian, or the blur is not needed to be fully looking at all the pixels. They can try to use different paths to make it a little bit more faster, but all of them in the end are going to rely on the Gaussian blur function. So what we are seeing here is a file that ends with GLSL, which is the language that is used to write fragment shaders. There are other languages. For example, in the Apple world, it's called Metal. In Windows, it's DirectX or whatever. Like, there are so many of these languages, but let's just call them fragment shaders for now. And here is one other sample. For example, if you use the latest version of Flutter and you deploy your application to Android 12 and more, if you take a closer look, it's no longer just doing the ripple effect that is a circle that gets bigger. If you actually zoom, or I don't know, maybe you have good eyes. It's not like me. You don't need to zoom. You actually can see it easily. It's sand that randomly drops behind the scenes, and that sand is randomly generated to look a bit more color, because randomness is beauty. So that's why it looks way more beautiful than a normal sparkle effect that is a circle that gets bigger. So this, we can go to the Flutter framework, and we actually find that they are used in the Flutter framework, not even in the engine. You can take a look. It ends with fragment shader. It can be with GLSL, but that's just the extension of the file. And now a question is, we have seen that all of the cool stuff is coming from fragment shaders. We have seen that by customizing them, we will be able to achieve some great stuff. Now let's go to do some practicalities and show you a little bit of code. I don't think I will be able to do live coding today, so I'm just going to show you the simplest code ever, and I will walk you through it. Yeah, had an early morning flight, and you know all the weather here this morning, right? They had to go like literally in the airport. They were scaring us. The pilot was saying, we're gonna go back now. We're gonna go back now because they will not allow us to land. Like, yeah, that's gonna be a long day anyway. So we have a very simple shaders application. This one is literally just the simplest shader we can ever have. You go here to create a new folder called shaders, and whatever you put there, just put .frag in it. And that .frag is an extension for to say that this is the fragment shader. This is the simplest we can ever have. It's a main function that looks like C++ code, but the only difference is that it has a frag color that we are setting the values for it here. I'm assuming you all know that these are just the RGB colors, and this is the alpha color. So what color is this actually? Is it red, blue, RGB? So it's so this has to be green, right? Okay, yeah. Let's see. Okay, yes, it's green. Wow. Yeah. So if this was confusing, taking a look at the other codes is definitely going to be more confusing. But the only thing I'm going to show you here is that this is the simplest fragment shader we can ever have. It's a main function. The input for the function is going to be some values that we'll provide from the Flutter side, but the output, there is only one output. There is nothing else you can do in the logic here. You cannot use like multiple, like you can use some logical operators like if, for, and all of that, but it's very limited. That's why it's a different language. They do not support like literally C++. It's very limited. You do not have access to the C++ standard library. You have very, very limited things that you can do, but what you have to know is that all what you are able to do here is going to be done super fast because it's done on the hardware and it's done per pixel all at the same time. So here we are rendering a color that is green. The setup is we write this file, we go to pubspec.yaml. We have, instead of, well, we have assets, but we have additionally shaders where we say all the shaders that we want to include in our application because they will need to be compiled before the app starts actually. And then the way we use them is we load them using this new API called fragment program. We say, it's coming from this file, then get me the fragment shader. It's asynchronous, it doesn't load synchronously, so that's why I'm doing async await here at the beginning. But then the good part is how do we use it? It's literally still using a custom painter, so we have to go back to thank the custom painter. Even though we say bad things about it, we still have to go back to it. The only difference here is that it's being hooked. It's not, we are not actually running the logic on it. We're not running any Dart code here. It's just delegating that logic to be running on the GPU at that point. But that's a very simple shader, and we'll be seeing more fun stuff in a bit. But that will be the first simple shader. It gets a little bit more complicated very easily, but what I'm showing you here is that the uniforms is the way to pass values from the Flutter side. So here I'm passing the color instead of just hard coding the color that will be the output. I'm just passing it, and in the Flutter side I'm passing it as RGB values divided by 255 because that's what they are expecting it to be. There is probably a better API to do that, but we are showing you the raw API here to explain how it works. Now, to demos, we have few demos for you. So all of these demos are demos I have been working on since 2022. So literally for 2 years, I've been just doing 2 demos. I think I promised myself one thing, which is to not learn how to write GLSL, but by now it's just by default. I know probably 2% of it, but I'm still not able to understand that language fully. So all of these examples here, I'm putting the code. All of you can take a look at how they are made, but I will provide the QR code at the end as well. So this is a button using the same method that we have seen, for example, the sparkle. This is a button that does a really nice hover effect. For example, you want to make people, I mean, I don't know if people are actually going to click on this button. They will be just hovering and hovering by. It's not very useful UX friendly, but it's very nice in the UI. But it shows an example of how we can implement that on a button. The other one is the blurs. So all the blurs that they have shown you are obviously were implemented in Flutter. Otherwise, I wouldn't have shown them to you. So I have this simple application here where all the types of blurs that we have implemented, and we can hopefully scroll between them. I guess scroll between them and see how they are implemented. Make sure that they are actually running fast as well, and compare them at the end by the Gaussian blur that is provided by Flutter. So all of these were like, you can take a look at the code of how you can actually use them in your application if you need one of those really custom blurs and you want to use them. Another one is very famous, at least in the latest version of iOS 17. If you look closely when you are scrolling at the edge of the home screen on your iPhone, you will see that the blur effect is no longer just strictly a shape that is completely trimmed. Like, you cannot tell whether you are in the blur side or you are not in the blur side. So it's called the faded blur. It's a very common design now in the iOS world, and obviously we can do it in Flutter. The reason I'm bringing it here, because I want you to remember if it gives you back any memories from any of the other blurs, because it's definitely not made completely from scratch. The blur is actually the one that we have seen here. That is called tilt shift. So tilt shift happens from the top to the bottom, but we have control. That's why we are doing the custom fragment shaders in the beginning, is because we want to be able to control them. So we have the tilt effect. We just apply it at the top because we can say a simple if condition to say, if the pixels are above this limit, then just don't apply the effect. As simple as that. So it's based off of it. And now we have another one. This one was just a random one that was asked by someone. Asked me how to do this. This is Instagram. So Instagram, when you click on a picture or a profile picture, they have a background that is blurred. But if you see in the details, it's not just blurred, it's blurred and pixelated at the same time. So called it pixelated blur, and you can take a look at the sample over there. This was actually just a challenge from someone saying that like the Android, they were comparing Android weather application with the iOS weather application, and they were saying that, come on, look at this. Why there are no designers in Android? Why does it look so bad? So I tried to actually get literally the same. It's going to take me a couple of years to get the same weather application that they have, because it gives a lot of work into it. But this one was a very simple one where we just show that you can tell what's the fragment shader here. It is the snow in the background. And it's running very smoothly here this is on an iOS, but they record this on Android just to make sure that they also know. This one is the one I made for the event. It's called the Mac Genie page transition. I have the code here very lightly. It's really just for learning practices, but you can see how cool the effect is when you're probably trying it on your device, because I don't know how to explain it, but once you feel it, it feels like you really are squishing something, because that was the only satisfying thing about it. Obviously, on the video, it looks like super weird, kind of, but when you're trying to play with it, it feels like a little bit more physical. So that's why I was probably clicking on it a lot. This is another one called blurry up bar. So you know how we have the effect where we blur the up bar at the bottom, and then that blur is always looking the same. So I tried to use the blurs that we have seen from other types of blur, for example, the glass blur. But the reason I did this experiment at the beginning, you will see it in the README, is the reason blur effect makes your app janky is because it's applied with very big values. So you say like apply it with 10 sigmas, 20 sigmas, and then you suddenly say 50 sigma. 50 sigma is going to literally kill the scrolling of your application. But the answer to that problem is, what if there is another blur effect that looks blurry, but we can achieve something that looks nice? Because we have to differently, like the Gaussian blur looks simple, but the reason we do it is because the reason we use a blur effect in the beginning is to make something beautiful and hide information. So if we can achieve that with something else, I mean, this is blurry. I mean, obviously, to me, it's blurry. So if I can achieve it with 10x cheaper on the GPU, then I will definitely do that. So that was the whole test here about blurry app bars. You can see in the README some documentation about use cases where this will be helpful. We have the 8th demo. This is a name drop for iOS. So if you put two iOS devices and you put them next to each other, and then it blows up, right? So that's an iOS thing. And with Flutter, we have access to Android and iOS. I made this on Twitter, and it blew up literally just because people liked it. But this is when it doesn't look cool, because it's by itself. But if you have two devices next to each other, it will just look cooler. And obviously, it doesn't share any data. It's just the animation. But it's made fully with shaders. The reason this is possible is because we have the blur. We have something I showed you at the beginning. Remember, water drop. This is where it's coming from. It's not like a random effect. It's like a water drop that's happening at the anchor, at the top center of that place there. And then we combine it with the blur with a little bit more math. We can actually finally end up to that one. This is the final one. I think we can show this one live because I have already published it live, and we can see it. So this is how it looks like. It's like very satisfying effect, and it looks like paper is being flipped. But on a modern application, this doesn't look like 2008. I mean, I don't know if you agree with me or not, but it definitely does not look like 2008. It looks a bit more modern. The code for that one is also available on a different repo. But those are the samples. Now, practically speaking, I just want to make sure a couple of things. The reason all of this is possible is because something recent in Flutter called GPU images. A GPU image, we used to do quite a lot of hacks in order, for example, if you want to take a screenshot of a widget, like you say you have a button and you want to transform that one to a PNG and send it. Or you have a view, a list view, and you want to transform that into a PNG and you want to use it. We had to use quite a lot of context, global key, asynchronous stuff to do that, so it wasn't very cheap to do, and it was hacky. But recently they have added something called GPU images, which is taking the images straight from the rasterizer that's happening literally at the last step of rendering in Flutter. They take that and give it to you synchronously. So whenever we apply that effect, we can apply it to the whole widget, to the whole application. For example, the iOS name drop, we just take the whole application and we draw the effect on it. It's not like the effect is happening on this widget or that widget. It's taking the whole thing and transforming it into an image. The reason it's possible is because it's coming from the GPU synchronously. There is a widget in Flutter. Not sure how many of you have heard of a widget called snapshot widget. I haven't heard of it until I started researching this. It's like a widget that literally just transforms your widget, or whatever is inside your widget sheet, can be your entire application, into a GPU image that you can apply these effects on. So a GPU image, let's take that name out of it, UI.image. So you can take a UI.image and you can play with it in a custom painter as much as you want. Snapshot widget is going to provide you with that. And one more thing, we mentioned image. Image has a memory load, so it can be very expensive if you're doing that. So that's one of the things I mentioned on the scrolling example. If you're doing it with scrolling, you're actually literally creating a lot of objects, and then the garbage collector is removing them at the same time. So it's going to be really expensive on the memory, and you might be kicked out by either Apple or Google at some point, because that will be using a lot of memory. So that's why it should be used only for short-lived animations. It's not me who was saying that, it's the Flutter team, because they also use it. They use this effect on the zoom blur when they transition from one page to the other. They actually use that. So what's going to use fragment shaders for? Some advanced visual effects. Some effects that are actually working, but we want to optimize them. Customization and control, because we literally have access to every single pixel on the screen. What other customization we can go over? And the more practical one is really real-time image processing. If your application is going to be targeting any of these use cases, it will definitely get some help from fragment shaders. Things you can take a look at. The very first thing is writing using fragment shaders. It's a document by Flutter team. The book of shaders is the only probably resource that you will be able to learn what kind of magic is being written in GLSL or Metal or any of those. It's basically in the basics, the most basic form, linear algebra, or on gas, whatever. Yeah, it's just that. And then we have Shader Tool, where you can find all the inspiration and the demos. Obviously, after you get all of that done, you will probably need some optimization on those shaders, because even though they are fast and they run on the GPU, you still can write terrible code that will actually make the application junk. So we will need to know how to make something efficient. The code for all of this is here, and that's it. If you have any questions, please let me know.